Welcome. In this video, we're going to review significant figure rules. The first question that I want to remind you about is, why are significant figures important? So let's consider taking a measurement. If you look at this measurement, you can see that the ruler is marked to every centimeter, and that the object we're measuring is between 13 and 14 centimeters. And so if you go and talk about what its measurement is, you might say, well, this is 13 and it's closer to the 14 than it is to 13, so I'm going to go 13.7 centimeters. Remember, you're always going to estimate between the lines and add one more digit, and that's the last digit with really any meaning, where you can actually intelligently tell someone, yeah, I think this is about what it is. And so that's going to dictate your significant figures for that measurement. What if it's a slightly different measurement? If I have a different tool and I go back to measure that same device or that same object, now I can see that it's still between 13 and 14, but since my ruler is marked out to the 10th place, I can tell that this is really 13.7, maybe 13.75 centimeters. So because my measuring tool has additional information embedded in it, then my measurement can have additional digits. The number of digits you're writing down in a number tells someone about how well you know that measurement. Tells you how precise your tool was. And so it matters how many numbers you write down. And that's where significant figures come in. They give us a way to keep track when we're doing calculations of how many decimal places out should your number be written to reflect how well the measuring tool gave us information, or how much information that measuring tool provided. So it's really important to use significant figures because it tells us about how well we know a measurement. Let's talk about how we count significant figures. So first, non-zero numbers, numbers 1 through 9, and zeros that are trapped in the middle of a number, these are always significant. So these will always count. So for example, in the number 546.8 inches, all four of these numbers are significant, and we have 4 sig figs. If you were to have a number like 30.05 grams, the zeros in the middle here are trapped, and so this also has 4 significant figures because those numbers are always going to be significant. Preceding zeros are never significant. So these are zeros that come before the first non-zero digit. So if I had a number 0.0073 centimeters, the zeros at the beginning are not significant. They are before the first non-zero number. Your first non-zero number is 7, and so that's where we'll start counting for significant figures. That only gets 2 significant figures. Trailing zeros are the ones that you'll have to really remember to pay attention to, because these are sometimes significant. Trailing zeros are significant if there is a decimal point. So, for example, if I have the number 10.00 grams, there is a decimal point in this number, and so all those zeros at the end count. They are significant, and this number has 4 sig figs. On the other hand, if I had the number 2,600 miles, as written, there's no decimal point in that number, which means that these final zeros are not significant, and this only has 2 significant figures. Let's take a look at the rules for addition and subtraction. When you're adding and subtracting, you are going to take your answer and you're going to round it to the last shared decimal place in your measurements. For example, if you had the value 16.8 grams and say you added an additional 0.39 grams of whatever that material was using a different balance, that gave you a different number of decimal places, then when you go to figure out how much solid you have, you have 17.19 grams, except that from that first balance, you don't actually know what that hundredths place value is. So when you go to report your final value, you need to round to the last shared decimal place, which in this case is the tenths place. So you'll take a look at the number to the right of where your place value needs to be, and you're going to have to decide, is what's following going to require me to round up or to leave the number where it doesn't round down? Well, 17.19 is definitely closer to 17.2 than it is to 17.1, so you would properly report this value as 17.2 grams. Similarly, if you had a length of material that was 35 centimeters and you came in and you cut off 8 centimeters, then what you'd be left with is 27.0 centimeters of material. But you don't actually know that it's 27.0 because you don't know anything beyond 8 centimeters. You need to round to that last shared decimal place, in this case the ones place, and 27.0 centimeters would be written as 27 centimeters in that case. Multiplication and division have different rules. In this case, you're going to round to your smallest number of significant figures in the measurements. So for example, if you're calculating the volume of a box and one side is 10.4 centimeters, the second side is 3.6 centimeters, and the third side is 0.8 centimeters for their dimension, when you multiply, your calculator tells you this is 29.952 cubic centimeters. But your measuring tool only gave you a certain amount of information. So let's go back and look at these numbers and figure out how many significant figures we have. This first one has 3, the second one 2, and this one only 1 significant figure, because this 0 is preceding and so is not significant. So when I come to my answer, I only get 1 significant figure. Well, that's this one. Everything else has to be taken away in the rounding. So I need to round to this tens place. I'll look at the number past it, and 9 is definitely above 5. And so I'm going to round up. And so this is going to be 30 cubic centimeters. Please note that this does only have 1 significant figure because I didn't add a decimal place to that value. So it's just 30 cubic centimeters. For division, it's very similar. So you'll take your two numbers. So let's say we're calculating a density of something. So I've got 48.65 grams of that material, and it occupies 8.7 milliliters of space. My calculator tells me this is 5.59195, but you don't actually know that much information about it. If you were to write that down, you would be misleading someone, thinking that you actually knew that measurement to a much higher degree of precision than you actually did. These two numbers, this top one has 4 significant figures, the bottom one only has 2, so I need my final answer to have 2 significant figures. So as I take a look at it, that means I get these first 2 digits and I have to round everything else away. So 5.5915, that is 5.6 grams per milliliter when written with the appropriate number of significant figures.